Yo, Wagwan. Yeah, man, it's Mr. Garfield here. And today we'll be looking at a Cape integrated mathematics question. All right. I'm focusing on trigonometry again, okay? Because this is another part of trigonometry that they can put into the exam. All right. Remember that your exam is fairly new, the syllabus is fairly new. So um, you haven't seen all different types of questions that they can actually bring into the exam. All right, now I have a question here that we're going to go through, but before I go through the question, let me go to your syllabus, all right, because I want to show you something there. So I'm going to share my screen with you. Okay, so you should be seeing my screen now. All right, as you can see, this is the Cape Integrated Mathematics syllabus. And I'm going to scroll down to the trigonometry section. Okay, that's module 1, Foundations of Mathematics. All right, so I'm going to scroll down here, right here. Good, this is the trigonometry section, right? Now, it says that students should be able to do what? Solve equations involving trigonometric functions, all right? And it told you that you will get functions of the form a sine of x plus b equals c, a cosine x plus b equals c, and a tan x plus b equals c. All right, where a, b, and c are just constants. Okay, I believe I did an example of the second case, a cosine of x plus b equals c. Okay, and I explained how to deal with the other cases, right? Because the process is really the same. All right, but I showed you exactly how to get the different angles and the different quadrants. So you can look at that video, all right, where the domain is a subset of x being greater than or equal to negative 2 pi, less than or equal to 2 pi. All right, so you're dealing with functions of this form, okay, and you're required to find principal, secondary, and other solutions by using the general solution. Notice that word, general solution. All right. Now, please note that you're not required to find the general solution, because if you were to do that, then they would have said it in the syllabus, right? But they wanted to use the general solution to find principal solution, secondary solution, and other solutions. Okay? So that is the aspect of trigonometry that we're going to focus on today. All right, so let's go back to our screen. So I thought about a question in which they can bring in the exam for the general solution. All right, and I found a perfect question that they could bring. Okay, which is the one that I have on screen here. So the question says the general solution of a trigonometric equation is x equals negative 1 to the power n cos inverse of a half plus n pi, where n is an integer. Find the solutions in the interval x being greater than or equal to negative 2 pi radians, but less than or equal to 2 pi radians. All right, this is a perfect question that they can bring in the exam. And many students might be shocked because they have never seen a question like this and they don't know how to attempt it. All right. So I'm going to go through this question with you step by step. So you have to know what is a general solution and what is its purpose. All right. So if you recall, so let me change my ink here. All right. So you remember you were given some trigonometric equation, right? So say for example, you were given an equation like 2 sine theta plus 1 equals 0, right? And they tell you that the values of theta lie between negative 2 pi radians and 2 pi radians, right? You know how to do this already, right? I'm assuming that you all know how to do this, correct? Now, what if they didn't give you this interval here? Right? So what if they never give you that? And they gave you this function alone, right? the general solution, so if I give you that trig function there, that trig equation there, and I tell you that the general solution is theta equals -1 to the power of n times pi over 6 radians plus n pi, where n is a member of the set of integers, right? So say for example, I give you that trig equation above, and I tell you that theta equals -1 to the n pi over 6 radians plus n pi radians, where n is a member of a set of integers. I tell you that this is the general solution, right? I tell you that that is the general solution of the trig equation above, all right, for this equation here. Cool? What that means is that if I plug in any integer value for n, right? If I plug in any integer value for n inside of this theta here, all right, for n, then I will get a solution to this trigonometric equation, all right? That is simply what it means, okay? Now, if you try and find the solution to this equation, all right, using a calculator, the first angle that you'll get, which is the principal solution, all right, that is your pi over 6 radians. You will get pi over 6, all right? But you already know that there are other solutions, otherwise I'm that, right? And normally they would give you a domain. So theta is between -2 pi and 2 pi radians, inclusive, right? So they would restrict the domain, all right? They would tell you what angles to look for, okay? But the general solution now is a case where suppose they didn't give you the restriction. Suppose they never tell you that theta is between -2 pi and 2 pi, right? The general solution would basically be a solution where you can plug in any value for n inside, and you always get a solution to the you will always get a solution to the equation, to this equation here, right? To that equation there. Okay? So say for example, n was 0, you will get theta equals -1 to the power of 0, which has a value of 1, multiplied by pi over 6, you get pi over 6, plus 0 times pi, which is 0, right? So you get theta equals pi over 6. That is one solution, okay? That is one solution. And if you should plug in n equals -1, all right? You could use a calculator, all right? So I'm not really putting the work in here, but you could use a calculator. If I have n equals -1, all right, and if I have n equals 1, sorry, and I put 1 for n, I will get -1 to the power of 1, which is actually a -1, multiplied by pi over 6. That will be negative pi over 6, all right? And then the other part now where it says n pi, that would be negative pi, right? But that's -1 times pi, which will give me a -7 pi over 6. That is also another solution, all right? And you can check it for yourself, all right? You can plug in these values of theta into the trig equation here in the box, and you will see that you will get 0, okay? Assuming that your calculator is in radian mode, of course, all right? So that's just a brief explanation of the general solution, right? Its purpose and what does the general solution mean, okay? And of course, you could go on and on and on. There are infinitely many amount of solutions, all right? There's an infinite set of solutions that you can use that will make this equation be satisfied, all right? All right, so that's it for that. So we're gonna focus on the question now. Okay, so let me just erase all of this here because we're not gonna need it, all right? Let's read the question now. It says that the general solution of a trigonometric equation is x equals -1 to the power of n times the cos inverse of a half plus n pi, where n is an integer. Find the solutions in the interval x greater than or equal to -2 pi, but less than or equal to 2 pi radians. All right. Now, I did this question in two different ways. All right. I'm going to show you the most simplest approach that I took to it, all right, because the other one will involve a bit more reasoning. So I'm going to give you the most simple approach. Let's write our solution here. All right, so now you know what the general solution is, what it means and its purpose. So they told us that x is equal to -1 to the power of n times the cos inverse of a half plus n pi. All right, so let us first find the cos inverse of a half, all right, into our calculator. We can put it in our calculator, or if you know the value out of your head, all right, you can write it down. So assuming that your calculator is in radian mode, of course, because we want our angles in radians, all right? So that's -1 to the power of n times the cos inverse of a half, which is actually pi over 3 radians, all right, plus n pi. And they told us that n is an integer, right? N is a member of the set of integers, okay? They told us that. Good. So what we need to know now is what values of n will give us a solution in the interval -2 pi to 2 pi radians inclusive. All right. So what we're going to do is just to substitute values of n into the general solution here and ensure that whatever solution that we get for x, it is within our interval. Okay. So if you remember the set of integers, those are negative whole numbers, positive whole numbers, including 0. All right. So what I'm going to do is I'm going to try from -3 to +2 and see what answers we get. Okay. So I'm going to say when n equals -3, what will be our value for x? All right. So you can work it out in your calculator. All right. I'm just gonna write down the answer here. So we're gonna have n equals -3. So when you substitute n as -3, all right, let me use my highlighter. All right, we're gonna substitute n as -3. Okay, so when you substitute n as -3, you'll get -1 to the power of -3. All right, multiplied by pi over 3. -1 to the power of -3 will give you -1 multiplied by pi over 3. That will give you -pi over 3. Okay, -pi over 3. And then we're going to have -3 times pi. All right, -3 pi. All right. Now, if you calculate that, you will get -10 pi over 3 radians. All right. Now, we have to check if this is within our interval that we want. All right. Remember that this is the interval that we're dealing with. -2 pi, 2 pi radians inclusive, right? Good. Now, just for you to note that this is the same as -360 degrees less than or equal to x less than or equal to 360 degrees. All right, that's the same thing. All right, that is equivalent in terms of the degrees. Okay, so what is -10 times pi radians over 3? All right, that is actually -600 degrees, which is outside of our interval. All right, that is outside of our interval. So I can just write to the side here. I can just write to the side here, outside of interval. All right, so outside of the interval. Which means that -10 pi over 3 radians is not going to be a solution. All right, so I can't include that as my solution. Okay, so I hope that was understood. So let us now try when n is equal to -1. All right, so as I said before, I'm trying from -3 to 2, all right, integer values. So when n equals -1, what are we going to get? X is going to be equal to, sorry, not -1, -2, right? -2. Then we're going to have -1 after, all right? So when n equals -2, we're going to have -1 to the power of -2, which is going to be a +1, multiplied by pi over 3, which will give me pi over 3, all right? Plus n pi. Remember, n is -2, so that's -2 pi, all right? And that, when you subtract that, you will get -5 pi divided by 3 radians, all right? So how much is this in terms of degrees? This is -300 degrees, which is actually in our interval, all right? -300 degrees is inside our interval. So it means that -5 pi over 3 is going to be a solution, okay? Good. So that is going to be our solution. So I'm going to try now when n is equal to -1. All right, when n equals -1. X is going to be equal to what? So when n is -1, we're going to have -1 to the power of -1, which is going to give me a -1 multiplied by pi over 3, which will give me a negative pi over 3. All right, and then n pi, n is -1, so that's -pi. Okay, so when we subtract now, we will get -4 pi over 3 radians. All right, and we have to now check if this value for x is inside our interval. Well, -4 pi over 3 is equivalent to -240 degrees. Okay, and as you can see, that is also inside of our interval. Okay, so that is also inside of our interval. So x equals -4 pi over 3 is indeed a solution. All right. So my other value now after -1 is going to be 0. So when n equals 0, x equals what? So you're going to have -1 to the power of n. N is 0, so -1 to the 0 is going to give me 1, multiplied by pi over 3, which will give me pi over 3. Okay, plus n pi. N is 0, so that's 0 times pi, which is 0. All right, so x is equal to pi over 3. Okay, so that is also within our interval. All right, because if you convert that now to degrees, you'll get 60 degrees. Okay, and if I go up a bit here, 60 degrees is within our interval here. Okay, so it means that this is also going to be a solution. All right, great. I'm going to try 2 more. So when n equals 1, all right, x is going to be equal to what? So we're going to have -1 to the power of 1, which is -1, multiplied by pi over 3. So that will give me a negative pi over 3. Okay, plus n pi, n is 1, so that's plus pi. All right, plus 1 pi, but you know we don't really write the 1. All right, and if you should add those two, you will get 2 pi divided by 3 radians. All right, and this is also within our interval because 2 pi over 3 radians is equivalent to 120 degrees. All right, as you can see, 120 degrees is within our interval there. Okay, so when x equals 2 pi over 3, we will also get a solution. So I'm going to try one more. When n equals 2, x is going to be equal to what? So I'm now substituting n as 2, so we have -1 squared, which will give me a +1, multiplied by pi over 3, all right, which will give me pi over 3, plus n pi, n is 2, so that's plus 2 pi. Okay, add those together, you will get 7 pi over 3 radians. All right? And 7 pi over 3 radians is equivalent to 420 degrees. All right? 420 degrees. Is that within our interval? No, it is not. All right? So I'm now going to put beside of it outside of interval. All right? So that is outside of our interval. All right? That is outside of our interval. Great. So what does that tell us? That is not going to be a solution, right? Now, let me now explain to you why I didn't go less than -3, right? Meaning why I didn't do negative n equals -4, n equals -5, etc. And why I stopped at n equals 2, right? Why didn't I go to n equals 3, n equals 4, etc. So let's start with the n equals -3 first. Now, clearly you saw that when n equals -3, that is going to be outside of our interval. So that means if I were to do n equals -4, okay, it means that it would also be outside of our interval. So any value less than or equal to n equals -3, right? Any value less than or equal to -3 would give me a value outside of the interval. And any value which is equals 2, all right, any n value which is equal to 2 or greater than 2 would also give me a value outside of the interval, okay? So that is the reason why I didn't go up to n equals 3, 4, 5, and I didn't go up to n equals -4, n equals -5, etc. All right, so how many solutions do I have inside of the interval? 1, 2, 3, 4 solutions. All right. So I'm now going to write a statement here now. I'm now going to write a final statement and I'm going to say hence. Okay. So I'm now going to say hence the solutions in the interval, the solutions in the interval -2 pi less than or equal to x less than or equal to 2 pi, all right, are, so the values of x which are greater than or equal to -2 pi but less than or equal to 2 pi are x equals, the first value that we got was what? X equals -5 pi over 3 radians, and that is a solution. Then we had x equals -4 pi over 3 radians, that is also a solution. X equals pi over 3 radians, all right? But we have one more. So, and x equals 2 pi over 3 radians, all right? So we have 4 solutions in total. That is inside of the interval there that was given, okay? So if this is the question that could come up in the exam, all right? And I'm sure that if a question like this came into the exam this year, students might be wondering what they are to do, all right? So I just wanted to go through a question like this as well, okay? So I hope you understood my reasoning behind the solution there, all right? And of course, if they bring a question like this to you, you should not have any difficulty in answering no, okay? Good. So I really hope that it was helpful, and if it was, please just leave a comment down below and like up the video. All right. I am Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.